Assalamu alaikum. Students, in last session we learned exercise 6.1, question number 1 to 4. The topic is sequences and series. And now we are going to discuss question number 5. Question number 5. In question number 5, how many terms are there in the arithmetic progression? And the given arithmetic progression is 2 upon 3, 1 upon 2, 1 upon 3, up to so on, whose last term is minus 17 upon 6. How many terms? That means we have to find n. How many terms are there in arithmetic progression? And the arithmetic progression is 2 upon 3, 1 upon 2, 1 upon 3, up to so on, whose last term is minus 17 upon 6. That means Tn is equal to minus 17 over 6. Solution. So the given arithmetic progression is 2 upon 3, 1 upon 2, 1 upon 3, and the last term Tn is minus 17 over 6. Here A is equal to 2 upon 3. A is the first term of the progression. And D is the difference, the consecutive term. So half minus 2 upon 3. Here LCM is 6. 3 minus 4. Minus 1 upon 6. So that difference D is equal to minus 1 upon 6. And the nth term is minus 17 over 6. Tn is equal to minus 17 over 6. And we have to find the number of terms n. Here using formula, is the general term formula, nth term formula, that is Tn is equal to A plus n minus 1 of D. It is applicable for arithmetic progression or sequence. The arithmetic progression is has the difference between two numbers is fixed. So put the value of Tn, and A is 2 upon 3, first term of the progression, plus we have to find n, and the difference is minus 1 over 6. Okay. Minus 17 upon 6 is equal to 2 upon 3. And this is n minus 1. Minus plus minus. This plus and minus. And we get n minus 1 upon 6. So minus 17 upon 6 is equal to, we take LCM. And the LCM is 6. 2 2s are 4. Sorry, this is 4. Minus n minus 1. 6 and 6 will be cancelled. Minus 17 is equal to 4 minus n. Minus minus plus 1. So we find the value of n. N is negative here, and after the equality, other side of equality will be positive. And 4 plus 1 plus 17. So n is equal to 18, 22. So in arithmetic progression, in the given arithmetic progression, the number of terms are 22. There are 22 terms. Since there are 22 terms in this progression, this will be answer. Okay. In question number 6, let's see question number 6. Which term of the sequence -3, 3, 9, 15 up to so on is 75 is part 1, and the second part is 6m minus 15. Which term of the sequence -3, 3, 9, 15 up to so on is part 1 is 75. Here we find uh, n is the number of term. So that given sequence is -3, 3, 9 and 15. Here A is -3, D is 3 minus -3, so D is 6, and Tn is equal to 75. So we use the formula, general term formula. Nth term formula is, by using nth term formula, we get Tn is equals to A plus n minus 1 of D. Here Tn is 75. This question is like question number 5. A is -3 plus n minus 1 and D is 6. So 75 is equals to -3 plus 6n minus 6. 75 plus 3 plus 6 is equal to 6n. 75 plus 9 is 84. 84 upon 6. Here n is 14. So the 14th term of arithmetic progression is 75. The result is, the required term is 14th term. And the second part of this question is same. In second part, the last term is 6m minus 15. The arithmetic progression is same, -3, 3, 9, 15 and up to so on. And this is the last term, Tn 6m minus 15. Similarly, here a is equals to minus 3 and d is equal to 3 minus 3, which is 6. And Tn is equals to 6m minus 15. As we know, Tn is equals to a plus n minus 1 of d. Last term is 6m minus 15 is equals to a is minus 3 plus n minus 1 and d is 6. So 6m minus 15 is equal to minus 3 plus 6n minus 6. Six m minus 15 is equal to minus 9 plus 6n. 6m minus 15 plus 9 is equal to 6n. We have to find the which term, the n. 6m minus 9 plus 15 is minus 6. We take 6 as a common and 6 is cancelled with 6. M minus 1th term is 6m minus 15. So the required term is m minus 1th term. In question number 7, the second, 31st and the last term of an arithmetic progression are 31 upon 4, 1 upon 2 and minus 13 upon 2 respectively. That means respectively means the second term is 31 upon 4 and the 31st term is 1 upon 2 and the last term is minus 13 upon 2. If we take the terms in the sequence, find the number of terms. Question number 7. The second term, that means T2, and the 31st term, that means T31, and the last term, that is Tn, of an arithmetic progression having difference same, are 31 upon 4, 1 upon 2 and minus 13 upon 2 respectively. Respectively means we have to take the terms in order. Find the number of terms. Solution. Okay, we know that the general term can be given as a plus n minus 1 of d, and in the data the second term t2 n is 2, a plus 2 minus 1 of d. Second term is 31 up. The second term is 31 upon 4. This is second term. We can write in place of second term 31 upon 4 is equals to a plus 2 minus 1 d, a plus d. We say this is our equation number 1. And the second condition is the 31st term is 1 upon 2. So after this, T31 is equals to A plus 31 minus 1 of D. The 31st term is, so the 31st term is 1 upon 2 is equal to A plus 30D. We say this is our equation number 2. And the last term Tn is equal to A plus and minus 1 of D, and the given last term is minus 13 upon 2 is equal to A plus n minus 1 of D. This we say equation number 3. We can eliminate by elimination method. We can subtract equation number 1 and 2 and get the value of one unknown, A or D. Because equation number 1 has two unknown variables, plus A and plus D, and equation number 2 has also plus A and plus 30D. If we subtract equation number 1 and equation number 2, we eliminate A. So, equation number 1 minus equation number 2 gives, here equation number 1 is A plus D is equals to 31 upon 4, and equation number 2 is A plus 30D is equal to 1 upon 4. Now we subtract these two equations, sign will be changed, and plus A and minus A cancelled. Here we get minus 29D and 31 upon 4 minus 1 upon 2. So minus 29D is equal to, we take LCM, 4 and 31 minus 2. So minus 29D is equal to 29 upon 4. 29 will be cancelled with 29. Minus D is equal to 1 upon 4. We get the value of D is minus 1 upon 4. Here D is equal to minus 1 upon 4. And put the value of D in any equation, equation number 1 or 2, we get the value of A. So we put the value of D minus 1 upon 4 in equation number 1. Equation number 1 implies, our equation number 1 is A plus D is equal to 31 upon 4. We put the value of D in the place of D minus 1 upon 4. Plus minus minus. A is equal to 31 upon 4. This is minus 1 upon 4 is negative here, and other side of equality will be positive 1 upon 4. After this we take LCM and find the value of A. This 4 is LCM. 31 plus 1 is 32. 32 upon 4 means 8. The value of A is 8. Now we have the values of both A and D and we find the value of N. So put the value of A and D in equation number 3. Put the value of A and D in equation 3. Our equation number 3 is minus 13 upon 2 is equal to minus 13 upon 2 is equal to a plus n minus 1 of d. Put the value of a and d, and d is equal to minus 1 upon 4. So minus 13 upon 2 is equal to 8 plus minus minus n minus 1 upon 4. Okay, now minus 13 upon 2 minus 8 is equal to minus n minus 1 upon 4. We take LCM 2. So minus 13 minus 16 is equal to minus n minus 1 upon 4. Minus 13 and minus 16 is minus 29. Minus 29 upon 2 is equal to minus n minus 1 upon 4. Minus sign we cancel with minus, and 2 2s are 4. So 29 multiplied by 2. Here 29 2 डिनोमिनेटर में, इक्वालिटी के अदर साइड पे जाएगा तो न्यूमरेटर में इज इक्वल टू n माइनस 1 अपॉन 4. 29 2s are 58 plus 1 is equal to n. Then the total number of term in the progression is 59. So n is 59. Since total number of terms is 59. Now the question number 8 is is 83 a term of the sequence 1 4 7 10 up to so on? The given sequence is 83. We take 83 as the nth term. Is 83 a term of the sequence 1 4 7 10 up to so on? One given sequence is 1 4 7 10. So here a is the first term, which is 1, and d is the difference. 4 minus 1 is equal to 3, and the tn last term is 83. We have to find is 83 a term of the sequence or not. So we know that the nth term formula is tn is equal to a plus n minus 1 of d. Tn is 83, a is 1 plus n minus 1, and d is 3. 83 is equals to 1 plus 3n minus 3. 83 plus 1 is equal to 3n minus 3. 83 plus 1 plus 3 is equal to 3n. So this is 87 upon 3. 87 upon 3 is equal to n. If we divide 83 sorry, 1 is positive, then other side of equality will be negative. 83 minus 1. So 83 minus 1, 82 plus 3, 85. 85 upon 3. 85 upon 3 is not a whole number. So it's not a positive integer. So 83 is not a value of any term, because the number of term is will be an integer. Since 85 upon 3 is not a positive integer, so n is not equal to 85 upon 3. 83 is not a term, is not the value of any term. Okay. Now we see question number 9. In question number 9, okay, question number 9. How many numbers are there between 256 and 789 that are divisible by 7? So first we find the divisible number that is divisible by 7 between 256 and 789. How many numbers are there between 256 and 789 that are divisible by 7? Okay. So the progression is 256, 257, 258, 259, 260 up to so on 789 having difference 1. We have to find the number that is divisible by 7. Numbers divisible by 7 are 7 between 256 and 789 are that we can find by simply divide by 7. Dividing by 7 we get the numbers that are divisible by 7. So the first number that is divisible by 7 is 259. After that 266. After that 273. And so on 784 are in arithmetic progression. We have to check the difference between these numbers will be same. The difference between 266 minus 259 is 7, and the difference between 273 and 266 is 7. So this is the arithmetic progression or sequence that number is divisible by 7, and these numbers are between 256 and 789. So here A is equal to 259 and D is equal to the difference between two terms. So 266 minus 259 is equal to 7. Difference is 7, is a fixed number. And the last term, last number which is divisible by 7 is 784. By using the general nth term formula, that is Tn is equals to a plus n minus 1 of d. Tn is equal to a plus n minus 1 of d. The last term is 784. First term is 259 plus n we have to find, and the difference is 7. 784 minus 259 is equal to 7n minus 7. This is 525 plus 7 is equal to 7n. So this will be 532 divided by 7 is equal to n, and 532 divided by 7 is 76. The value of n is 76. There are 76 numbers between 256 and 789. Therefore, there are 76 numbers between 256 and 789. This was question number 9, and the question number 10 is find the first term, the common difference of the arithmetic progression when 4 term is 7 and 16 term is 31. Question number 10 has 3 parts. In the second part, its 8th term is 7 and 11th term is minus 23. And its fifth and 10th terms are 86 and 146 respectively. That means fifth term is 86 and 10th term is 146. We take in order. This is the same as we have done question number 5. No, question number 7. So here we do only one part, and the next part you can do easily. Find the first term and the common difference of arithmetic progression when the first part is T4 is equal to 7 and T16 is equal to 31. So the 4th term is 7 and the 16th term is 31. Solution. Let A be the first term and D is the common difference, and D be the common difference. So the general term formula Tn is equals to A plus n minus 1 of D. Here the 4th term is equal to A plus n is 4 Fourth term is 7. A plus 3D is equal to 7. We say this is our equation number 1. And the 16th term, similarly, the 16th term is equal to A plus 16 minus 1 of D. The 16th term is 31. A plus 15D. This we say equation number 2. We find the first term and the common difference of this arithmetic sequence. We subtract these two, equation number 1 and equation number 2, and get the value of A and D. Equation number 1 subtract with equation number 2 gives, our equation number 1 is A plus 3D is equal to 7, and the equation number 2 is A plus 15D is equal to 31. We subtract A plus A minus A will be cancelled, and here we get 12D is equal to 31 minus 7 is 24 is equal to, minus sign cancel with minus sign, 12 2s are 24. The value of D is 2. Put the value of D in any equation number 1 and 2, we get the value of A. So the equation number 1 implies A plus 3D is equal to 7. We put the value of D in the place of D and get the value of A. So A is equal to 1 and common difference is equal to 2. This is the required values of A and D. Question number 2 and 3 are same as question number part 2 and part 3 is same as part 1. So you can do easily. Question number 10. In question number 11, show that the sum of the P plus square term and the P minus square term of an arithmetic progression is equal to twice the Pth term. For this we find first Pth term and then P plus square term and then P minus square term, and by adding P plus square term and P minus square term we get the answer which is equal to twice of Pth term. The sum of the P plus square term and P minus square term of an arithmetic progression is equal to twice the Pth term. Solution. Similarly, we say that let A be the first term and D be the common difference of an arithmetic progression. Pth term, we know that the general term is Tn is equals to A plus, and a term is A plus n minus 1 of D. So the pth term is a plus p minus 1 of d. Pth term is equal to a plus p multiplied by d and d. This we say our equation number 1. And the next is we find the p plus qth term. So n is p plus q. A plus p plus q minus 1 of d. So p plus qth term is a plus p into d plus q into d minus d. This we say equation number 2. And similarly we find p minus qth term, and p minus qth term is a plus p minus q minus 1 of d. This will be a plus p into d minus q into d minus d. This we say equation number 3. According to given condition, p plus qth term, the sum of the p plus qth term and p minus qth term is equal to twice of pth term. This is our given condition. So we put the values of t plus qth term, which is a plus p into d plus q into d minus d. This is our p plus qth term. And the p minus qth term is a plus p into d minus q d minus d. Is equal to twice of our pth term is a plus p into d minus d. So a plus p into d q d minus d plus a plus minus qd minus d is equal to a plus minus d. So a plus a is 2a and p into d plus p into d plus 2pd and plus ka qd is cancelled with minus ka qd and minus d minus 2d. We can take 2 as a common. A plus p into d minus d is equal to, so the right hand left is equal to left right hand. Right hand side is equal to left hand side, or left hand side is equal to right hand side. So hence this is proof the sum of the p plus qth term and p minus qth term is equal to twice of pth term. So the question number 12. Prove that nth term का square of nth term minus twice of t and n minus 1th term का whole square plus n minus 2th term का whole square is independent of n, where nth term stands for the nth term of an arithmetic progression, is independent of an where T and nth term stands for the nth term of an arithmetic progression. Solution. Let A be the first term and D be the common difference. Of an arithmetic progression. We know that nth term is A plus n minus 1 of D. So this is the nth term, and the nth term A plus n to D minus D. We say this equation number 1. And then n minus 1th term, we can write n minus 1th term in this form. So n minus 1th term is equal to A plus n minus 2 of D. So T n minus 1 is equals to A plus n into D minus 2D. This we say equation number 2. Similarly, n minus 2th term is equals to A plus n minus 2 minus 1 of D. A plus n minus 3 of D. So n minus 2th term is A plus n into D minus 3D. This we say equation number 3. According to given condition, we put this equation in the given condition, that is according to given condition, nth term का square minus twice of n minus 1th term का square plus n minus 2th term का square is independent of n. So we put the value of nth term and the n minus 1th term and n minus 2th term in this expression, and after simplification we get the expression which is independent of n in the form of D or A, maybe we get the expression. So we call this is independent of n. So you can prove by yourself easily by putting this expression in this expression. We discuss question number 13 here. If W, X, Y, Z, W, X, Y, and Z be four consecutive terms of any arithmetic progression, then show that W square minus Z square is equal to 3 times of X square minus Y square. So W is the W, X, Y and Z be the four consecutive terms That means W is the first term and X is the second term and Y is the third term and Z is the fourth term. Let A be the first term and D be the common difference. Of an arithmetic progression. We know that the nth term formula is Tn is equals to A plus n minus 1 of D. So T1 is equal to A plus 1 minus 1 of D. T1 is equal to A and the first term is W. We say this is equation number 1. And the second term is T2 is equal to A plus 2 minus 1 of D. So T2 is equal to A plus D. We say that this is X and our equation number 2. Similarly, the third term is A plus 3 minus 1 of D. So T3 is equal to A plus 2D. A plus 2D is equal to Y. This we say equation number 3. And the fourth term is A plus 4 minus 1 of D. Fourth term is A plus 3D, which is equal to Z. So according to question, these are our 4 consecutive terms. And we have to show that W square minus Z square, which is equal to the value of W is equal to A square minus the value of G is just A plus 3D, the whole square is equal to A square minus, here we use A plus B का whole square, A square plus 2AB plus B square So here W square minus B square is equal to A square minus 6 AD minus plus minus minus 9 B square. Plus A square minus A square will be cancelled. So W square minus B square is equal to minus. We take 3D as a common. Minus 3D as a common. So 2A plus 3D. This is the value of W square minus Z square. Now we take right hand side. This is left hand side. Taking right hand side. Which is x square minus y square. So we put the value of x and y. The value of x is a plus b का whole square minus the value of y is a plus b का whole square. Here we use a plus b का whole square. This is a square plus 2ab plus b square minus a square plus 2ab plus b square so this is okay 3a square plus 2ad plus b square minus a square minus 4ad minus 4d square. So 3a square plus and minus. Here we get 2ad plus minus 4ad minus 2ad plus का d square minus का 4d square minus 3d square. We take minus d as a common for making same as left hand side. So here 2a plus 3d. So minus 3d is equal to 2a plus 3d, which is equal to left hand side. Hence, it is proved that w square minus d square is equal to 3 times of x square minus y square. Similarly, in question number 14, if B, C, P, Q, R are the arithmetic progression, prove that B plus R is equal to C plus Q and is equal to 2P. Let B, C, P, Q, R are in arithmetic progression. So, first we when we okay, if okay, in question number 14, if B, C, P, Q, R are in arithmetic progression, prove that B plus R is equal to C plus Q is equal to twice of P. Okay, solution. Let B, C, P, Q, R are in arithmetic progression. So, if it is the arithmetic sequence, the difference between two terms or consecutive term will be same. So, C minus B is equal to D and P minus C is equal to D. Similarly, Q minus P is equal to D and R minus Q is equal to D, and the difference, all differences are same. So we say this is these B, C, P, Q are in arithmetic progression. Okay. So we have to prove B plus R is equals to C plus Q is equals to 2P. We say this equation 1, this equation 2, equation 3, equation 4. Okay. From 1 and 4, we have one is C minus B is equal to R minus Q, because the difference are same. So C plus Q, uh, we have to prove C plus Q is equal to B plus R. So C plus Q is equal to minus B will be positive, B plus R. This we say equation 5. And similarly from 2 and 3, we have 2 is P minus C is equal to 3 is Q minus P. So P plus P is equal to Q plus C or C plus Q. So 2P is equal to C plus Q. This we say equation number 6. So by comparing the value of C plus Q from 5 and 6, we have B plus R is equal to C plus Q is equal to 2P. This is what we have to prove. So in question number 15, if x, y and z be the pth, qth and rth term of an arithmetic progression, show that if x, y and z be the pth, qth and rth term of an arithmetic progression, show that in determinant sign p, q, r, x, y, z 1, 1, 1 is equal to 0. So solution is similarly, let A be the first term and D be the common difference of an arithmetic progression. So pth term, because in this question if x, y and z are the pth, qth and rth term of an arithmetic progression, so x is the pth term, y is the qth term and z is the rth term. So pth term is equal to a plus p minus 1 of d. We get from this nth term formula Tn is equal to a plus n minus 1 of d. So pth term is x. So a plus p into d minus d. This we say equation number 1. And the qth term is tq is equal to a plus q minus 1 of d. And y be the qth term. So this is equal to a plus qd minus d is the equation number 2. And z be the rth term. So tr is equals to a plus r minus 1 of d. So z is the a plus r into d minus d. This we say equation number 3. So from here we get the value of p, q and r. From equation number 1 implies x is equal to a plus p into d minus d. So we find x minus a plus d is equal to p into d. X minus a plus d upon d. This is the value of p. And similarly, equation 2 implies y is equals to a plus q into d minus d. So y minus a plus d is equals to qd. Y. From here we find the value of q. We solve this for value of q. Y minus a plus d upon d is the value of q. Similarly, equation 3 implies a plus rd minus d is equal to z. So a minus d minus z is equal to okay. So rd is equal to z minus a plus d. So r is equals to z minus a plus d upon d. This is the value of r getting from equation number 3. Wait. So we put this value of p, q and r in the determinant. We know that the determinant is p, q, r, x, y, z, 1, 1, 1. We have to show this is equal to 0. Implies put the value of p, which is equals to x minus a plus d upon d, and the value of q is y minus a plus d upon d, and the value of r is z minus a plus d upon d. X, y, z. Symbol of determinant will be straight. 1, 1, 1. Determinant symbol is like mod. So by expanding any with respect to any row or column, we get the value which is equal to 0, and we have to show that the determinant is equal to 0. Expand with respect to any row or column, otherwise you can use properties of determinant. So by using expansion or properties of determinant, we have proved that this will be equal to 0. So you can do this is by yourself. It shows that x, y, and z of arithmetic progression by we can prove this easily. So this is the last question of this exercise. Thank you so much.